Natasha Chopra, software engineer and strategist with Intel, supporting technical ISV enabling, and I work closely with Microsoft on end customer SQL Server ISV enabling for mission-critical solutions. I'm going to talk a bit today about mission-critical computing with Microsoft and Intel. Intel and Microsoft have collaborated for more than 2 decades to create scalable, high-performance solutions for mission-critical computing. Intel Xeon processors and Windows Server 2008 R2 running Microsoft SQL Server 2008 R2 are the culmination of those efforts. Companies can reduce TCO and gain scalable performance and advanced reliability benefits by migrating to this joint platform from RISC and Unix servers or by upgrading older Intel and Windows servers. Scalable Intel Xeon processor-based servers are performing mission-critical computing. This demo uses a server based on Intel Xeon processor 7500 series, which represents a quantum leap in data center computing. Applications that were once solely the domain of mainframe class or RISC-based systems can now run on a platform built using highly scalable Intel Xeon processors without sacrificing performance for as low as 1/5 of the cost. Further performance, security, and efficiency gains are possible with the successor, the top-of-the-line Intel Xeon processor i7, 8800, 4800, and the 2800 family. It's designed for your critical business needs. The ability to power large-scale and mission-critical applications is the result of the following scalability improvements. Servers built using the newest Intel Xeon processors can execute compute-intensive throughput workloads up to 40% faster than the previous generations. Servers built using the newest Intel Xeon processors can support up to 2 TB of memory for each 4-socket glueless configuration, and 8 times improvement from the previous processors. Servers built using highly scalable Intel Xeon processors are available in glueless configurations of 2 up to 8 sockets. A glueless design is one in which processors are directly connected to each other through Intel QuickPath architecture. This design provides high-speed connections between microprocessors and external memory and between microprocessors and the I/O hub. With OEM-specific node controllers, a design in which memory and I/O connections between sockets are managed by a third-party chip, some servers can expand up to 256 sockets. That's a 16 times improvement from the previous generation Intel Xeon processor 7400 series. Scalable Intel Xeon processors offer up to 8 times the memory bandwidth of previous generation processors. Intel Xeon processors have consistently added scalability and performance with each new generation. As measured by the TPCC benchmark, newer scalable Intel Xeon processors deliver a quantum leap in performance with up to 2.8 times the OLTP performance than the prior generation and up to 5.6 times greater performance than the previous Intel Xeon processor 7100 series. In April 2011, Intel continued this pattern of increasing scalability with the release of Intel Xeon processor i7 family. This processor family features up to 10 cores, support for up to 20 processing threads per socket, and up to 2 TB of DDR3 memory for even greater density, performance, and scalability. With the ability to scale up to 256 logical processors per operating system instance and support for up to 2 TB of RAM, Windows Server 2008 R2 takes advantage of the scalability of Intel Xeon processors, forming the ideal choice for ultra-dense, large-scale applications. At the same time, SQL Server 2008 R2 has increased the number of logical processors it supports from 64 to 256 for increased performance in addition to better scalability. The server we're using for this demonstration is an NEC A1080a. This server is equipped with 8 Intel Xeon 7560 processors, each sporting 8 cores and 1 TB of memory. This means that there are 64 physical cores in the server with 128 logical cores available in Windows due to the Intel hyper-threading technology. With the basic Windows resource monitoring tools, we can see that there are indeed 128 logical processors available in Windows. Now we will take a look at this joint platform in action, showing how Intel Xeon Processor 7500 series, Windows Server 2008 R2, and SQL Server 2008 R2 combine for a highly scalable platform. Of course, scalability goes beyond simply counting processor cores. Newer Intel Xeon processors incorporate other key technologies and features that are used by Windows Server 2008 R2 to further assist with scaling. First, let's look at core parking. This feature intelligently consolidates processing into the fewest number of cores possible, suspending any inactive cores that result. Provided by the processor and supported in the operating system, core parking reduces power consumption and provides processing power exactly when you need it. As the server sits idle, the system parks cores that are not in use. Let's see what happens when we increase the server load. We can see that all the available physical memory, 1 terabyte, is also available to Windows. This increased capacity is enabled by Intel's scalable memory buffers, which handle memory transactions between processor's memory controller and the DIMMs, offloading the buffering, management, and other overhead to the processor. This results in faster memory performance at greater capacity, opening up the door for greater scale-up. As mentioned previously, it is possible for systems like this to scale well beyond this mark using node controllers. Although this demo environment incorporates a glueless architecture and is not equipped with node controller designs are available for large-scale deployments. Although OEMs have scaled previous generation Intel Xeon processor-based platforms to higher processor counts, the architecture wasn't designed with that in mind. For those OEM who want to go larger, the architecture explicitly incorporates the notion of a node controller that connects together dual-socket or quad-socket nodes. The Intel Xeon Processor 7500 series and E7 family are therefore ready to support up to 8-socket 64-core designs out of the box and are designed to support up to 256-socket servers with extensions from OEMs. As you can see, servers built using scalable Intel Xeon processors running Windows Server 2008 R2 have the scalability features needed to run large-scale and mission-critical applications. The applications that previously required costly RISC-based mainframe-class platforms. I hope that this has been informative for you today, and thank you for watching.